and we're going to talk through the whole process, okay? But I want to make sure you guys can do it algebraically, because if you can do it algebraically, you understand what you're doing. And if you can do it algebraically, you can always do it, right? Whether you have a calculator or not. So I'm going to show you how to do that first. And make sure you guys are following along. You're going to need a blank sheet of paper because there's going to be a lot of writing here. All right, 14, sure. Let's go ahead and do 14. All right, so it starts off, it says, an arrow is shot upward with an initial velocity of 64 feet per second from a platform that is 32 feet high. Guys, 32 feet high. Look at that's what it would look like to be shot from 32 feet high, right? It's almost like it is a y-intercept. It's the same concept as like a line, right? Okay, so the height of the arrow is determined by this equation. Now this equation is not talking about, again, the distance from where it's shot. It's just talking simply how high it is given the time, right? It could be shot to the right, left, straight up. It doesn't matter. It's just height versus time, where t is the time in seconds and h is the height in feet. So it says graph the equation. Okay, this is given in the context of you using your calculator. Let's do it without a calculator. Okay, so we're not going to graph the equation. All right, where is the arrow at 2.5 seconds? Okay, the arrow at 2.5 seconds. How do you figure that out? Remember, first of all, this is an equation given height. It's height given time. If you give me a time, I'll tell you how high it is. That's what this equation does, right? If you give me a height, I'll tell you the 2 times, because it's a second degree function, I'll tell you the 2 times that it's at that height. Does that make sense? Because, think about it, it's a quadratic. It goes up and it comes back down. There's 2 times that it's at any given height, except the vertex. That's the only height that it's there one time, okay? So, it says, where's the arrow at 2.5 seconds? So what are you trying to do here?
Plug 2.5 in.
Plug 2.5 into what? T, the time, right? And it's as simple as that. All this is just a combination of plugging into t or plugging into h. Plugging into t or plugging into h of t, right? That's all it is, every single time. You just have to understand the context well. All right, so we're going to plug into t. So we have the height given time. So check this out. H given how much time? So y'all understand a little bit function notation. H of 2.5, right? Height given 2.5 is 32 plus 64 times 2.5 minus 16 times 2.5 squared. So somebody actually, I need you guys, somebody on the calculator going with this stuff.
92.
The whole thing is 92?
Yes.
So h of 2.5, so you can write it out like this just to practice. H of 2.5 equals 92 feet. Everybody good with that? Again, our focus is understanding the actual math. Then we can use the calculator, but let's understand what we're doing. So when is the arrow at 32 feet? Now it gives me, what, a height or a time? It gives me a height. How many times will it be at 32 feet? Twice, okay? So let's go ahead and solve for that now. So when is the arrow at 32 feet? Well, you solve for that by doing something like this. So 32, that's h of t, right? Equals, here's the rest of the equation. 32 plus 64t minus 16t squared. Everybody good with that setup? All right, now what's going to happen with these two 32s? Yeah, our whole objective is to set it equal to 0, right? And I hope everybody sees, without me actually writing minus 32, right? I hope everybody sees that, okay, when you have two 32s on the same side, or opposite sides of the equation, they just balance each other out, right? Does that make sense? So those are gone. So really we have 0 equals 64t. Actually, hold on a second. I'm going to write it the other way, or way that you guys are used to seeing it. Negative 16t squared plus 64t. Everybody good with that? I just switched the b and the a term. Right? Okay. Now I need to solve this. Some things are factorable, but is everything factorable? No. Everything will be solved using the quadratic formula. It can be solved using the quadratic formula, right? So if you feel comfortable factoring this, great. Attempt it, right? If you cannot factor it very well, you can always use the quadratic formula. Always. Okay? I'm going to factor it because what I see, and if you're good with numbers, you can probably see it too, 16 and 64. And I see t and t, right? So I'm going to pull out 16 because I know it goes into 64 4 times. So I'm going to pull out negative 16 and a t from each of these. And left over, I'm going to have negative 16t squared divided by negative 16t is just a t, right? And then 64t divided by negative 16t is negative 4. So if you're good at factoring, great. That's how you're factoring. Okay? If you're not good at factoring, what always works? Quadratic formula. So look, if I was using the quadratic formula, I'll set it up. I'm not going to solve it. You guys should have the confidence in yourselves to solve the quadratic formula now, right? Here's the setup, though. Negative b, negative 64, plus or minus the square root of b squared, 64 squared, minus 4 times a, negative 16, times c. Is there a c? Does that mean I don't put anything there? That means I put the numerical value that it doesn't exist. Times 0, okay? Over 2 times a. 2 times negative 16. There's the setup. That's what x equals, okay? You solve all that, you're going to get your answers. And guess what those answers are going to be? Based on this factoring right here, guess what those answers are going to be if you solve it? Anybody have a guess? 0 because of that, and 4. Those are the 2 times. Those are the 2 times that it's at 32 feet, right? The question was, when is the arrow at 32 feet? That's how you solve it. So keep it all in context, right? The first thing we did was we set that equation equal to 32. Plugged it in for h, right? And we solved it out. That's when it's at 32 feet. There's 2 ways you can solve it. You could solve it by factoring. You could also try to use the quadratic formula, right? If you use this, great. That'll work out too. You'll get 0 and 4. Okay? Got it? Any questions?
Oh, it's height times time, correct? And then in that example there, you only had height. So what I don't get is what happened to the time. ht equals whatever comes after.
H of t, height given time. So we're trying to find the time. We know the height is 32. So h of t is just another way of saying height.
So
Right.
there's no time included?
Well, there is, but that's what we're looking for. And that's literally what we just solved for, right? I used the variable x here. But that's what we just solved for. T equals 0 and t equals 4. Those are the 2 times that the height is 32.
Okay.
Okay? Any other questions? Okay, make sure you guys are following, all right? Okay, let's keep going with it. So we know 0, 0, and 4 seconds. Okay, what is the maximum height of the arrow? Does anybody remember how to do this? Remember I said it's a super valuable thing. You guys don't know it yet. You don't understand how valuable it's going to be. But it's very valuable. What was I talking about?
Was it the negative b over 2a?
Yeah, how do you remember it was negative b over 2a? It was, yeah. Do you remember? Does anybody remember where that comes from? Negative b over 2a?
The discriminant.
The quadratic, right? Not the discriminant. Everything but the discriminant.
Take the discriminant.
Yeah. So if you got rid of this quadratic, or the discriminant of the quadratic formula right there, this negative b over 2a, that's the x value of your vertex. Okay? So how do we find the maximum? Does everybody, I hope, some people probably see where I'm going with this. I'm finding the vertex. Now the vertex is either the maximum or the minimum, right? The question is, what is the maximum height of the arrow, right? So by finding the vertex, I find the maximum. You get it? So negative b over 2a. So negative b over 2a. Negative b is going to be negative 64 over 2 times a. Remember, a is right here. So over 2 times negative 16. So that's negative 64 over negative 32, which equals 2. Okay, well, that's not the maximum height, but what is that?
The time.
That's the time it takes to get to that height.
Then you plug 2 in.
Y'all understand that? That's, so my vertex is 2, comma, something, some height, right? So, Roy, what'd you say?
Plug it in 2 into the
Right, so
formula.
the calculator.
Formula.
Come on, man. No,
Formula.
I got you. All right.
Formula.
So plug the 2 into the formula for the time, right? And we'll see what the maximum height is. So I need somebody to go ahead and do t squared, which is 4 times negative 16, negative 64 plus, okay, I think I got this figured out. So it's going to be 64. Without taking too much time, plug 2 in, it should be 96. Yes, it should be 96, okay? So plug the 2 in, we get 96. So and in 2 seconds, we reach the maximum height of 96 feet, right? So that answers a lot of the next questions. What is the maximum height of the arrow? 96 feet, right? How long does it take to get to that height? 2 seconds. What does the vertex mean in this case? Well, it means that the arrow that's shot up takes 2 seconds to reach its maximum height of 96 feet. Y'all got it? Yes, we're good? Are there any questions so far? Okie doke. So going on. Write that out however you want. Again, something along the lines of it takes 2 seconds for the arrow to reach its maximum height of 96 feet.